Dear students, very good morning to all of you. So I welcome you to this session of information security. So today we'll be doing different substitution ciphers. So the various substitution ciphers which we have left in the previous lecture were Playfair cipher, Hill cipher, polyalphabetic cipher, and one-time pad. We'll try to complete all of these in today's lecture. So first is your Playfair cipher. So So Playfair cipher was invented by Charles Wheatstone in 1854, but it was named after Lord Playfair, who actually promoted the use of ciphers. So it was invented by Charles Wheatstone in 1854, but was named after Lord Playfair, who actually promoted the use of ciphers. Now, the algorithm for Playfair cipher is that you have to create a matrix of 5 by 5. This is a standard matrix which we will create. Fine. So we will create a matrix of 5 by 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is our step number 1. Then insert the value of key which is given to you and remaining letters into the matrix, and I and J will be combined together. Since there are 26 alphabets in our English, but we have total 25 spaces. So wherever I will be there, it is a rule that we have to combine J over there. For example, the key which is given to us is Abhi. So you will write A, B, H. Now I is there. So combine I and J. Okay. Then put the remaining letters into the matrix. AB is there. Now C, then D, then E, then F. You will not repeat the letters which have come in the key. So C, D, F, we will put G. Don't put H, don't put I, don't put J. Then put K, L, M, N, O, P, Q, R, S, T, U. Then you will be putting V, W, X, Y, Z. This is our step number 2. I repeat. First of all, substitute the key abhi. For example, sometimes in key we have some words. Like for example, we have this word occurrence. Right? Now the word C is repeating, R is repeating, E is repeating. So you will not repeat the alphabets. You will simply put it once. Fine. So for example, this key is given to you as abhi, A, B, H. Wherever I is there, put slash and put J. Okay, then C, D, E, F, G, K. Then remaining alphabets of English you will put here in the same sequence. L, M, N, L, P, Q, R, S, T, U, V, W, X, Y, Z. Okay, so this is done. This is done. Now, whatever the text is given to you to find, you will convert that text in the pair of two alphabets each. For example, the text is given to you as Heya. So he and ya. So you will convert into a pair of two alphabets each. For example, rule number 4. If some alphabet is repeating itself, M, H, E, double L, O. So L is repeating twice. So after the first occurrence, put X. HEL, then put X. HE, LX, and LO. Wherever there is repeated alphabets, break it at the first occurrence and append X to it. So HELXLO. For example, another word is given to you as this HELLOE. HELXLO. Now E is remaining. Only E is remaining. Only E is remaining. If single letter is remaining, append Z to it. If single letter is remaining, append Z to it. Okay. HELLO, HELXLO. then HE, HE break occurrences of L and X, LX, then LO, then EZ. Just append Z with the single letter which is left, and wherever the letter is repeated, just append X to it. Okay. So this is what algo is all about. So we can repeat the steps as: first, create a matrix of 5 by 5 we have created. Insert the key. We have inserted A, B, H, I, Abhi. Where Abhi is coming, append J to it. At the same place, we have to write J. Then put the remaining alphabets C, D, E, F, G, H. We have completed the sequence till Z. Then convert the given text, whatever text you are given for the encryption, convert the text, plain text, into the pair of 2. Okay. Then, for example, wherever the letter is repeated, break that letter from that particular occurrence. First occurrence say, so you have to break it up, then append X to it, then HELLOE, for example, this kind of text is there, HELX, we have broken down the repetition by using X, and if single letter is remaining, append Z to it. If single letter is remaining, append Z to it. Okay. So what are the rules? I'm going to erase this all because we have to follow some rules. First rule, you have broken the key into pairs. If both the alphabets of the key plain text, if both the alphabets of the plain text appears in same row, replace them with the alphabets or letters, immediately write to it. I'll give you an example once I'll write to it. For example, this is BH. You have your text is having some BH. So immediately write of B is H, and immediately write of H is I or J. So you can write HI or HJ. So this will be the key for BH. If some text is having BH as a pair, so B's right is H and H right is I. So if you can replace it with either I or J. That means BH plain text will be encrypted as HI or HJ. BH is the plain text which is encrypted as, this is ciphertext for BH. It will be encrypted as HI or HJ. Second, if both the alphabets are in same row, same column, same row we have done, same column, then replace them or replace them with the letters immediately below them. For example, you have been given L or Q. So these are both appearing in the same column. So immediately after L is Q and immediately after Q is V. So for plain text, LQ, you have QV, because the letters immediately below L is Q and below Q it is V. So we will replace them. Okay. Rule number 3. If they are on the corners, supposingly Q and Z, if both the alphabets lies on any corner, replace them with opposite corner alphabets. Replace them with opposite corner alphabets. For example, supposingly we have been given this L and U. So these are the corners L and U. So they will be replaced by DQ. So LU will be replaced by DQ. Similarly, for example, this is a text which is given to us. For example, this is the thing. So P is there, S is there. So you are going to replace it by N and U. Suppose P and S is given to you. So P and S will be replaced by N and U because they are on the different corners, and so the other corner will replace it. PS will be replaced by N and U. So three rules are there. First, if they are appearing in the same row, just replace them with the letters, immediately write to it. If both the alphabet in same column, replace them with the letters which are immediately below it. And if they are lying on the corner, then replace with the other corner pair. Okay. Now, supposingly you want to break this off, and X will be appended here. Then if I write greet, GREXET, because we have to bifurcate it from the very first occurrence. Okay. Then if some word is like free, FREE, then FREXEZ. FREXEZ. I should write it here because I think light is falling on it. EX and EZ. FREX and EZ. Okay, this is for free. This is how you will break up. Now let's, for example, plain text is given to us as greet. Now how will you find the encrypted text for it? Just break it up into three pairs, GR, EX and ET. Okay. Now locate for GR. I'm just removing everything. A key will be always given to you. And plain text will be always given to you. You have to break it up and then find. Okay. GR. So G is at this and R is there. G and R. Okay. So they are at corners. So place them with other corner. So let it be ET. Now EX. E is here. Where is X? This is there. E is here and X is there. So they are corners. So replace it with FW. Opposite pair is F and W. Okay. Now ET, E is there and T is there. So replace them with GR. Okay. So for example, other plain text we can take as BM. This is PT. We have to find the CT for it. RW, FG, UQ, QW, KL, and KS. Okay. So first of all, BM, B and M, they are appearing in same column. So replace them with the letters below them. Below B is E and below M is R. Same column. So they are replaced with the letters which are immediately below them. RW. Where is R? This is R and W. Below R is W, and below W we have to come to the it will come rotatingly to this position. So after B, we'll start from the first position again. Below B we consider, below W we consider as B. So they are in same column. Below R is W and below W is B. Okay. F, G. F and G. So it will be in the same row. Immediate right to F is G and immediate right to G is K. Then U, Q. So U is here and Q is here. So they are appearing in the same row. So immediate right to U is Q because it will come again rotatingly. And it will become Q and immediate right of Q is R. Now QW. So they are the opposites. So replace them with other corner, RV. Then KL. K and L. So they will be placed by DP. KS. K is there and S is here. Then replace them with F and U. Replace them with F and U. So that means this is the corresponding ciphertext for these given pair. Okay, using the Playfair cipher. Using the Playfair technique. So make matrix of 5 by 5 for this key. Now all the alphabets are different. Every alphabet is different. Okay. Now A is there, write on B. Then C is not there, D is not there, E is not there, F, G, H is here, so don't do it. I, then J, then K is not there. Okay, C is there. Sorry, I did it wrong. D, H is there. I, J, K, write L, M completed, N completed, O completed. P, Q, don't put R, S, T, then Q, V, W, X, and Z. So these are all covered. See, MONARCHY, then completed with the rest of alphabets. For example, I just want to decode your name. So SC, IJ, and AL. Now find SC, S and E. Replace it with I and L. Fine. So now I and J are coming in the same part. You will repeat the corner letter twice. I and J are coming so you will repeat the corner letter twice. So give it LL. Okay. Or then A and L. A and L. So they will be replaced by M and S. So now what hacker will think? This LL will stand for a single letter, that is I or J. He will not be able to figure it out. Fine. So this is your ciphertext for the given plain text Sage. Okay. Next is your Hill cipher. It was developed by Lister Hill in 1929. This was developed by Lister Hill in 1929. So it encrypts a given text in polygraph, like you did in play for cipher in pairs. Here we will be doing it in the form of polygraph. Polygraph means it could be a digraph. Digraph means which contains two vectors, or trigraph, etc. Same formulas which we did in Caesar cipher will apply here. That is C is equal to Kp mod 26. Kp, K is my key, P is my plain text, and mod 26 because we have 26 alphabets in English. Okay. Now, what is the algo? Choose, first step is to choose a matrix, I mean key matrix. Choose a key matrix which is a square, which is a square. Choose a key matrix which is a square. Fine. For example, you are taking view. 2 and 2 means any key which is a combination of 4 letters. So you will write it like view. So what will be its values? Starting A from 0 till Z, you will go till 25. So value of V would be 21, I is 8, E is 4, and W is 22. You can write assuming A equal to 0, B is equal to 1, C is equal to 2, D is equal to 3, up to so on till Z, you will say it is equal to 25. So this is your key, which is a square matrix of 2 by 2. You can even choose the square matrix of 3 by 3. For example, the keyword is quickness. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 letters are there. So this will be a matrix of 3 by 3. So I'll erase the upper one. Quickness. Put the values of A as 0, something like that. So Q comes at 16th position, U 20, and I at 8. Then C 2, K 10, and N 13. S is 18, and this is 4. So this is the key of 3 by 3. Okay. Now how to encrypt it, I tell you. For example, now how to perform the encryption. Plain text is given to you as attack, and key is given to you as 2, 3, 3, 6. This is 2 by 2 matrix. So that means first of all, you should convert this plain text into vector length of 2. 80, TA, then CK. For example, plain text attack is given to you. 2, 3, 3, 6 is the key which is given to you, and you will, first step is to break this alphabet into the pair of 2 and form a vector like this. 80, TA, CK. Now decode its value. First vector. Now we will start. Now this is 2 into 1. Okay. So you will take the key because we have written the formula P into K mod 26. So encryption starts here. So how it will be done? That is 80 is to be multiplied with 2, 3 and 3, 6. Okay, so this is your plain text. This is your key. Then we will do mod 26. Okay, corresponding to A, we have value 0. Then corresponding to T, we have value 19 because S is having 18. And you are going to perform the matrix multiplication. First row with this column, and you will write 2 into 0. It is not visible, I think. So do it here. 2 into 0 plus 3 into 19. Then multiply this 3 into 0 plus 6 into 19. So 2 zeros are 0 and this is 57. 19 threes are 57 and 3 zeros are 0 and you will get 114. 0 plus 114 mod 26. So 57 mod 26 and 114 mod 26. 26 twos are 52. So you will get 5 and 114 when you divide by 26, it will give you 10. It will give you remainder 10. So corresponding to 5, what we have the text is F and K is at this. So this is a cipher text equivalent of 80. I repeat, A, C, when you write, I write here, A equal to 0, B is equal to 1, C is equal to 2, D is equal to 3, E is equal to 4, F is equal to 5, then G is equal to 6, H is equal to 7, and I is equal to 8, J is equal to 9, and so on. We can get it. K is equal to 11, sorry, K is equal to 10, L is equal to 11, then M is equal to 12, N is equal to 13, O is equal to 14, and P is equal to 15, Q is equal to 16, R is equal to 17, S is equal to 18, and T is equal to 19. Now, because this much is required, that's why I'm written. Corresponding to A, we have 0. Corresponding to T, we have 19. So multiply this matrix. You know matrix multiplication. Add it up, 57, 114, mod 26. When you divide it by 26, it will give you 5 and 10. Corresponding to 5, what we have is this F, and corresponding to 10, we have K. So ciphertext equivalent of 80 would be FK. Okay. Similarly, you will do for TA. Similarly, we will be doing for TA. TA would be reverse of it. T and A. So it would be 19, 0. Fine. And matrix multiplication will give you two into 19 plus 3 into 0. Then 3 into 19 plus 6 into 0. 19 threes are 57 and 19 twos are 38. So 38 and this. So when you divide 38 by 26, it will give you 12. And 57 divided by 26 will give you 5. So equivalent of this would be 12 is equivalent to M and 5 is equivalent to G. So for this you have FK and for this you have MG. Okay. So sorry, MF because 5 is corresponding to F. Okay. Now you will write CK. C and K. So value of C is 2 and K is 10. Okay, now you multiply it. So 2 into 2 plus 3 into 10, then 3 into 2 plus 6 into 10. So 4 plus 30, 34. And 3 into 2 is 6, 6 plus 66. 66 divided by 34 divided by 26 will give you 8. It will give you 8 and 66. 26 twos are 54 or 52, sorry, and we will get 14 here. So what you will get is you will get I and O. You will get I and O. So now corresponding ciphertext. Corresponding ciphertext would be AT, TA, CK. For CK it is IO. For TA it was MF. And for AT it is FR. FK, sorry. So FK, MF and IO will be the ciphertext for the given plain text that is attacked. This is how you will do it. Monoalphabetic ciphers uses one fixed alphabet only, whereas polyalphabetic is a substitution cipher which will use multiple alphabets for the single alphabet in the plain text. So they may be different at different places. So there are two types. One is Wigner cipher, another is Vernam cipher. So first of all, we will do the Vernam cipher. Then we will come to this Wigner cipher. So this is the polyalphabetic substitution technique, Vernam cipher. Vernam cipher is the polyalphabetic substitution technique. For example, there is moon. One O will have encryption as suppose P. Another O will have encryption as R. That means two occurrences will have two different alphabets. Two occurrences of the same alphabet have two different alphabets as the ciphertext for the same alphabet. Now, how to do it? For example, plain text is given to you as hello, and key is given to you as A, B, B, X, Y, C. This is key which is given to you. You will not take the case into the count because this is lowercase, this is uppercase. According to you, sky values will be different. But here we are assuming it as capital. So I'll write, in order to avoid confusion, I'll write capital. Okay. So first of all, what you will be doing, this is encryption part. First write in plain text, HELL. So corresponding values in the alphabet table will be 7, 4, 11, 11, 14. then B, A, X, Y, C. So this is having 0. B is having 1. This is 23, 24, and 2. Okay. So this is your key value. Now add PT and key. You have to add plain text and key as well. So 7 plus 1 would be 8. 4 plus 0 would be 4. 23 plus 11, 34, 35, and 16. Wherever the total exceeds 26, wherever the total exceeds 26, subtract 26 from that particular figure. So 8, 4, 26, 34 minus 26 would be 8, and 35 minus 26 would be 9, and this would be as it is. So this is your encrypted key. This would be your encrypted key. And find the values I, E, I, J, then you have G. So hello will be sent as I, E, I, J, I, E, I, J, G. Fine. Now how to decrypt it? First of all, I repeat the encryption. Hello. Then find the corresponding numbers of these alphabets. Then key, find the corresponding numbers of these alphabets. Add plain text and key. You will get something like 8, 4, 34, 35, and 16. Now, wherever the figure is greater than 34, subtract 26 from it. Subtract 26 from it. Then you will get the figure as 8, 4, 8, 9, 16. And find the corresponding alphabets. You will get I, E, I, J, G. Okay. So now how to get the decryption part? Suppose you have received this key decryption. Text received is I, E, I, J, G. So key for it, values, decoded values for it will be 8, 4, 8, 9, and 16. Then write down key. Key will remain same 1, 0, 23, 24, and 2. Now you have added PT and key. यहाँ पे you will subtract it. You are going to subtract key from the cipher text. This is CT now. So subtract the cipher text from key from the cipher text. So you will get 7, 4, 23 minus 8. You will get minus 15, minus 14. Sorry, minus 15 and minus 16 here. Fine. You'll get minus 15 both the places. And this is 14. Now, wherever the figure is in minus, add 26 to it. Wherever the figure is in minus, add 26 to it, you will get 11. So 11, 11, 14, 4 and 7. And when you decode this, this is equal to 7, 4, 11, 11, 14. So it is HELLO. I repeat, the cipher text is received as IEIJG. Decode it, you will get 8, 4, 8, 9, 16. Then you will write the key as it is. Then subtract the key from the given cipher text. You will get 7, 4, minus 15, minus 15, and 14. Then wherever the figure is in minus, you are going to add 26 to it. Then you will get this positive numbers 7, 4, 11, 11, 14, which will be decoded as HELLO. So first is your beginner cipher that we will be doing today. We have two methods of beginner. One method we'll be completing today only. Beginner ciphers. So we have two techniques. It was designed by Blaise de Wigner. It is also a polyalphabetic substitution technique. Okay. Now, so the encryption is done using the Wigner table, which is of 26 by 26. The Wigner table is in front of you on your screen. You can see the matrix is in the form of 26 and 26. Capital alphabets, which are given on the left hand side, are keys. Capital alphabet A, B, C, D, E. These are your keys. And A, B, C, D, this is your some plain text which will be matching. Fine, I'll tell you how to match it. I'll just tell you. So this is on the left hand side is your key in the table, and this is your plain text which we are going to match. Now, for example, plain text and key is given. That is, give money and lock. Okay, so make a matrix in this form. PT and key. Write down G I V E M O N E Y. Fine. So okay. Now what happens is you put lock LOCK. Then repeat this because number of alphabets in the key are less. So again repeat it till the end. LOCK, then L alphabet it will have. Now corresponding to L, we have to see in this table where L lies, and corresponding to plain text you have to see in this line. You have to find the intersection of key and plain text. So the text is in front of you. So find the alphabet which is corresponding to L and your plain text G. So it is highlighted in the given table. G is made a little circle. A circle is made on G, and key is on the left hand side where capital L is given. Find the intersection of L and G. What you will get? You will get an alphabet. Which alphabet you will get? It is R. Which alphabet you will get? It is R. See, are you getting R? L corresponding to G. We are getting R. Similarly, corresponding to O on the left hand side and I, you will get W. Then I'll show you one more table which is more clear, I think. Just wait. See this table. I think this is more clear. If you can switch the video, just wait, I'll let you this way. Now see the key. It is clear. Key is on the left side and plain text is on the upper side. Now you can find the intersection of I and O, and V and C will give you X. Then you will get O. Then you will get X. C P O R W O XO J. So this you'll be getting, you can ensure it from the table. Left hand side is key. I mean, to the vertical side it is key, to the horizontal side it is plain text. So you can find the intersection of key and plain text, and you will be getting these letters as the encrypted text. Fine. Now, how to do the decryption? How to do the decryption? Now assume these letters as the ciphertext. R W X O X C P O J. Now again do the same thing and you will get give money. See, R is the key and sorry, R is a plain text and L is the key. Go to line number, key number L, and go to, you have to go to R. Under R, what you are finding? Again, you will find the intersection of key and text, ciphertext. Then you will get the text as give money. This you can do by yourself as table is there. So get the screenshot and do it. So I'll show you the second technique of this Wigner ciphers. So second technique is very, very interesting that we can do in here only. So when table is not given, how will you do it? So ciphertext will be equal to Pi plus Ki mod 26, and the decryption will be equal to Ci minus Ki mod 26. Simple. Okay. I will do it for the word she. For example, this is given to you. She is listening. First encryption, then we will do decryption. Okay. So she, S comes at 18 position. So values you will decode. H is coming at 7. This is 8. This is 8, 18. 11, 88, 18. Then E is at 4. 13, 8, 13, and G is at 6. Now key is given to you as 15, 0, 8, 15, 0, 18, 2, 0, 11. This is the string which is given to you. So write down the key 15, 0, 18, 2, 0, 11. Then again, I'll write it once again. Okay. Now write down value, P's value 18, 7, 4, 8, 18. Then you have 11, 8, 18, 19. Then E's value is 4, 13. Then you have 8, 13 and 6. So this is the decoded value of this text. Now repeat the key 15, 0, 18 to 0, 11. Then again 15, 0, 18 to 0, 11. Then 15, 0. Okay. So you have to add up these and find the mod of it. So 18 or 5, 8 and 5, 13, 33, 22, 10, 18, 22, 15 and 8 is 23, 18, 19 and 18 is 37, 4 to 6, 13, 19, then 28, then 6. Okay. Now, what we will be doing, wherever the value is greater than 26, subtract 26 from it. Subtract 26 from it. Fine. You will get 33 minus 26, you will get 7. This is 7 again, 22 again. You will get 10, 18, 22, 23, 18. Then 26, you will minus, you will get 11. 6, 13, 19, 22, sorry, 2 only and 6. This is what you will get as cipher text value. Corresponding cipher text would be H, H, W, K, then S, W, X, then SLG, SLG, N, T, C, and G. This is what cipher text would be. I repeat, she is listening, converted it into the code, then repeat the key until the end, then add it up and subtract where it is greater than 26. When you even do the mod, you will get the same value. So when I find the mod, you will get the same value. So 33 minus 7 or 33 minus 26, so you will get 7 as a remainder. So you will get this thing. HHWK SLGNTCG. So this will be your encrypted cipher text. This will be your cipher text. Now how to do the decryption? Decryption formula for decryption is cipher text minus key. Cipher text minus key. Now I am taking it here. Cipher text is 7722 10 18 22 23. Then you will get 18 11 6 13 19 2 and 6. So this is the cipher text value which we have taken. Okay, cipher text, this is key. So subtract cipher text from the key, you will get You will get minus 8 here. Then you will get 7 minus 0 is 7. 15 minus 7 is 8. 7 minus 0 is 7. 22 minus, sorry, 7 minus 15 is minus 8. So 7, 4. 10 minus 2 is 8. 18 minus 0 is 18. Then you will get 22 minus 7 is 11. 23 minus 15 is 8. 18 minus 0 is 18. Minus 7. 11 minus 18 is minus 7. 4. 13. 19 minus 11 is 8. 2 minus 15 is minus 13. And 6 minus 6 is 0. Okay. So now wherever the value is minus, add 26 to it. So you will get 18. Then you will get 7, 4, 8, 18, 11, 8, 18. Then minus 7 plus 26. You will get 19 here. Okay. Then you will get 4, 13, 8, 13 here. Okay. Then you will get 0. If you decode this, this is S, H, E, I, S, listening. This is how it is decoded. This is how it is decoded. So thank you so much for today's lecture. So we will be covering polyalphabetic substitution technique in the forthcoming lectures. So thank you so much. So now it's the poll time. Okay, if you have any if you have any doubts or any questions, you can ask